So it says solutions, roots, zeros, and x-intercepts. It's very important that you understand all four of these words mean the exact same thing. If I ask you what are the solutions to the quadratic, I'm asking you what are the x-intercepts. If I say what are the roots, I'm asking you what are the solutions. If I ask you what are the zeros, I'm asking you for the roots or the solutions. It's all the same thing. It's different words you'll see on different tests. Like at the end of the year on the ESC, you might see the word roots. But as juniors or seniors, you might see the word solutions on the ACT. So you need to know all the words, okay? So when we solve a quadratic, the solutions are the x-intercepts of the graph. So graphically, we can see here we have three possibilities. So what would it look like to have two solutions to a quadratic? Two x-intercepts. So how could I draw a parabola so that it crosses the x-axis 2 times? Use your words. Where does the vertex need to be?
On the
-6.
Like what?
The vertex should be
In the very middle, negative. Below.
negative, and the parabola should open up. That is, in fact, one possibility. Because look, one x-intercept, two x-intercepts.
Or it could
It
be
could open-
positive.
Or, Avery, the vertex could be
Positive and frown.
above, and it could open down. It can frown.
Be quadrant 1.
But once again, that is two x-intercepts. So those are basically the two scenarios to have two solutions. So what this might look like, remember, the solutions are the solutions to the factors. So this would look something maybe like this algebraically. So if the factor is x plus 2, what's the solution? X equals -2. And if the factor is x minus 4, what's the solution?
Positive.
X plus 4. X is 4. So what that means, those are the x-intercepts of the quadratic. So that means this parabola crosses at -2 and +4, and it opens up. We could do a little bit more work if we wanted to find the vertex, but most importantly, those are the x-intercepts. You don't have to draw that, that's okay. I'll read it to you. Okay. How would I have to draw the parabola so that there's only one solution?
Oh, I got you.
Alyssa?
The vertex is on the x-intercept.
Awesome, good vocab. The vertex is on the x-axis. Does it matter if it opens up or down?
No.
No, either one would work. But basically what that means is the factor happened twice. So maybe you factored and you got x plus 2 and x plus 2. Well, what's the only answer that I'm going to get out of both those factors? -2. That just means that the parabola is on the x-axis and it's crossing at -2. So it might look something like this.
No.
And lastly,
Oh, I got you.
there's no solutions.
Over here.
Karen?
All right, so it's in the above the x-axis.
Okay, good. So the
facing
vertex
up,
is above the x-axis
facing up,
and it opens up.
and below the x-axis facing down.
Or we could have a scenario where the vertex is below the axis and opening down. That means there's no solutions. But algebraically, what we're going to get is imaginary ones.
Oh my goodness.
Not cool.
Technically, still apply the line here.
What?
What do we need to know about imaginary?
Okay, so here we go. In order to undo an exponent, x squared, we must take the, how do we undo a squared?
Square
Square root.
root.
So now that we kind of see how these solutions relate to the graphs, we're going to solve some more quadratics today and kind of see what that means, the different ways to solve it, okay? So it says when solving quadratics, every time you take the square root, you must include the plus or minus sign. We read this as plus or minus. There are actually two answers. Think about it. If we have x squared equals 4, what are the answers that x could be? What number squared gives me 4? 2. That's not the only answer, though. -2, right? What's -2 times itself? +4. So we have two answers. The answer to x squared equals 4 is 2 and -2. So what we do, anytime we take a square root, the square root cancels out the square, right? So we get x equals And what's the square root of 4?
2.
2. But it's not just 2, it's also negative 2. There's two answers. So the way we write this is plus or minus 2. That's just kind of a combined, said that weird, combined way of writing positive 2 and negative 2. You can just say, hey, we have the positive and negative version of this number. So it's really two answers. Okay, so let's do example 1. How could I solve this quadratic equation? What should I do first?
Add the 7
Good, so we could add the 7 over.
over.
That cancels, which gives me x squared equals
16.
16. Good. Square root both sides.
Ooh.
So x equals
Positive or negative?
positive or negative 4. There's two answers to this problem. So how many times did that parabola cross the x-axis?
Couple times.
A couple times. Twice.
That's how you write the positive.
Yep. See.
What's
Okay, what about, okay, so graphically, let's think about this for a second. Where does this parabola cross the x-axis?
Plus or minus -4.
Positive 4 and negative 4. And would this parabola open up or open down? Look at the a value. It's a positive 1, so it would open up. So this parabola would look something like this. Okay. Example 2. We would subtract over 4, right?
Sure.
So we get x squared equals negative 25. Square root both sides. Uh-oh.
X equals positive or
So x equals plus or minus. Really what this is the square root of negative 1 times the square root of 25, right? We've done this before. The square root of negative 25 is the square root of negative 1 times the square root of positive 25. But what's the square root of negative 1? It's I. And what's the square root of 25? 5. So our final answer is plus or minus 5i. What does that mean about this quadratic?
It's imaginary.
Are there any x-intercepts? No, there are no x-intercepts. That's algebra's way of saying, hey, this parabola never crosses the x-axis.
Never once.
Okay, going on. Speaking of, why are we not factoring these quadratics? Because I thought we had to factor quadratics to solve them. One wasn't imaginary.
It's a prank.
They
have an answer.
could be set equal to 0. I could subtract that 120 to the left.
Please don't.
What's making it so I don't have to factor?
Because you're solving for an X.
You're not solving for y.
Avery's on the right. There's no x. There's no b term. Do you see that?
I see.
Remember, we factor
Oh,
when we have ax squared plus bx plus c equals 0. And what's nice about these is there's no x term in the way. So you can just subtract the c over and square root. Okay, so this is how we solve when there's no bx term in the middle. If there is a bx term, the only way to solve is by factoring. Okay, so we'll see some of those here in a minute. But let's go ahead and finish this off. Let's do example 3. So what do I need to do first on example 3? Add 12. So we get 3x squared equals 132.
Divided by 3.
Divide by 3. So we get x squared equals
44.
and now we
Square
square root, cancel, we get x equals, what do we always have to remember?
Plus or minus.
Plus or minus the square root of 44.
There's a square. Oh, wait.
It's not a perfect square, so we're not going to get a perfect whole number answer, but you always have to simplify your radicals. So if we do a little dates to prom, we would get 22 and 2.
11.
22 would be 2 and 11. Dates, staying home, dates, x equals plus or minus 2 square root of 11. Now, you guys, every year, like, people freak out, like, oh my gosh, 2 squared root of 11, what is it? This is like a crazy answer. What is it? That's just a decimal, right? Like 2 squared root of 11 is about 6.6. That just means that the parabola crosses the x-axis at 6.6. It's just not a pretty answer. Okay? So, it still crosses the x-axis. It's still a number. It's just a decimal. Okay? It's not anything different than x equals 5. It's just a decimal answer. Okay? Do example 4 on your own real quick. So first we would add 22 over, which gives us
32.
How do I get rid of a 1/2?
Multiply.
Double it.
There's two ways. You can divide by 1/2, and you can do that in your calculator. You just type it in like this. So 32 divided by 1/2. Or you can think of it the other way. How many halves does it take to make a whole? 2. So if you just multiply both sides by 2, 2 times 1/2 cancels out. We get x squared equals 64. Regardless, you'll get the same
Wouldn't
thing.
you technically do that first if you were doing this?
Doesn't matter. The multiplication and division go together. And then we square root, x equals 12. 8. Not just 8. Plus or minus 8. You guys, if you don't put plus or minus on the test, it's going to be wrong. There's your fair warning. That's a totally different. You're telling me there's only one x-intercept by only saying 8. There's 2 x-intercepts. You're missing half the problem. So you have to remember that. So this parabola would cross at positive 8 and negative 8, and it was compressed, and it opens up. So it looked probably something kind of like this. So all that stuff from graphing parabolas we learned at last test all still applies. Okay, we got a couple more examples. Let's do number 5 together. Then I'm going to have you do 6 on your own. So first step, what would I have to do? No. You cannot distribute into a squared.
You subtract 6!
You would not subtract the 6, you would add the 6.
You get rid of the 6.
Okay? So this is kind of like absolute value. Remember absolute value? We need to get everything away from the parentheses.
Divide by 3.
So now, instead of distributing the 3 through, which you can't do anyways because it's the parentheses squared, we're going to get rid of it. How do you undo multiplication?
Divide.
Yeah, so we're just going to divide the 3 totally away. So that cancels. We get x minus 4 squared equals 1. Okay, now,
You said it 3 times.
how do I undo something squared? You square root it. Well, this is x minus 4 squared. I can square root that. Even though it's in parentheses, as long as it's one thing squared, and it's the parentheses squared, we can square root it. So I'm going to square root both sides. And basically that gets rid of one of the x minus 4s, right? The square root cancels out the square. So now I'm just left with x minus 4 equals,
Square root of 1.
which is,
1.
and
Negative 1.
plus or minus 1.
That's not the answer.
What? We're going to. But you have to do the plus or minus now, okay? So now, basically what this means, kind of like, remember like absolute value, we split it apart, we did one positive, one negative? It's really the exact same thing. Because basically what this is saying is we have x minus 4 equals 1, but x minus 4 also equals negative 1. X minus 4 equals plus n minus 1. So we do our 2 separate equations, add 4 over, and what's one of our answers? 5. Add 4 over, and our other answer is, whoops, x equals 3. So you get 5, and you got 3. That means this parabola crosses the x-axis at 5 and 3.
Oh, I got one.
All right, do number